Here's my explanation of what radians are, okay? Pretend, so use your imagination, that you're standing in the center of a track, but instead of an oval, it's a perfect circle. Are you there? Are you envisioning it? You're standing in the middle, perfect circular track around you. You're watching your friend go run around the track. Degrees would represent the amount you need to turn in order to watch your friend. So you're standing in the middle of the track. You just have to rotate in order to keep them in your sight. So you would be standing like this. Your friend is going around. Degrees is this. You just rotate. Are you coming with me on that? Like, you're not actually moving. You just spin. That's degrees. Radians is what your friend is doing, is they're actually moving around the circle. Now, this was all nice and color coded, but the printer printed it in black and white. But do you see how this amount gets taken and put right there? That's like the radians, okay? I have it all written out here so that you don't have to write it down. 1 radian is the measure of a central angle, which we call the angle theta, that intercepts an arc. This is an arc. We're going to talk about arc length later, the arc of the circle right there. Equal in length to the radius of the circle. However, here's the thing. If you have a small circle versus a bigger circle, the distance traveled is going to be different if you have a small one versus a bigger one. And we can't have that be the case because you can't have it be different for every single circle. We have to like standardize the measurement. So we divide by the radius, and essentially what that means is you sort of ignore the radius of the circle because we want it to work for a circle of any size, all right? So you take the distance traveled, divide by the radius of the circle. Here's the important thing to remember if you're going to put a star or underline something. Both degrees and radians are units of measurement for an angle. It doesn't matter if it's in radians or degrees. That's theta. An angle is theta. Okay, degrees or radians, that's your angle. Like the capital letters, A, B, C. The trig functions, that's sine, cosine, tangent, those are a ratio of the sides of the triangle. Do you remember opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, all that stuff? Those are the trig functions. They are a ratio of the sides. So degrees and radians are an angle, trig functions, those are the sides. And here's the goal, is for us to be able to convert between degrees and radians. It's like converting between inches and feet. How many inches are in a foot? 12, and you use that 12 inches to 1 foot to do a conversion. Not to like spark any horror here, but you know how in chemistry you convert to moles? Do you know what I'm saying? Okay, it's like that, okay? But it's gonna be okay, all right? A full circle has 360 degrees. So a full circle would have how many radians for us to do the conversion? Here's the hint. If you run the whole way around a circle, you have traveled the distance of the circumference. So here's degrees. Our degrees would be 360. That's the whole way around. We have to figure out what that's going to be in radians the whole way around. I always throw this question out here because usually there's like one person that remembers. If not, I'm obviously going to tell you because I'm your teacher and I'm teaching the lesson to you. But does anyone remember the formula for a circumference of a circle? What is the circumference of a circle formula? Oh, there's a 2 in it. Good. Oh my gosh, good. See, that's why I always ask, because somebody's always got it. Nice job, guys. 2 pi r. Now here's the thing. We ignore r. Because if you have a little circle versus a bigger circle, you know, the r is going to mess that up. The radius is going to be different for all of them. So 360 degrees is 2 pi radians. Now we're going to reduce that because dealing with smaller numbers is better than dealing with bigger numbers. So if you divide those both by 2, 360 divided by 2 would be 180. 2 pi divided by 2 would be pi. Now, if you didn't listen to anything I said, here's the too long didn't read version, because I know some of you are like, I don't care why, just tell me what the answer is. And I get that, okay? Here's the too long didn't read version. If you want to change degrees into radians, you're going to multiply by pi over 180. That's like the 1 foot to 12 inches conversion. And if you want to change radians to degrees, you're going to multiply by 180 over pi. So if you didn't listen to anything else I said, that's it. That's your conversion, okay? So flip over the page. We're going to do a whole page of conversions. You're going to be all right. The only thing is you don't get a calculator for this, so you might need to do like a side problem to work it out. Some people have like a calculator in their head, which I'm jealous of, but I always just write everything out. So we're just going to do a bunch of conversions. All right. 30 degrees into radians. You're going to take your 30 degrees. And I suggest writing the degree symbol because you'll see it cancel out. You're going to multiply by, oh, and I see you looking back already. To turn that into radians, you're going to multiply by pi over 180. And then you just have the job of reducing that down. Today is going to be kind of like fun with fractions, okay? But do you see how the degree symbols cancel? That's why I suggest writing them in there. And when you go to reduce it, these zeros also cancel, which is nice. So you get 3 pi over 18. And then what would that reduce to? What would 3/18? Get 1/6, so pi over 6. That's essentially all there is to it. It's just the fractions might get a little bit messy at some point. All right, so let's do 90 degrees. Multiply it by pi over 180. Again, if you put that degree symbol in there, it'll help you remember whether it's pi over 180 or 180 over pi, because you have to get them to cancel. And then the zeros will also cancel. You'll have 9 pi over 18. And then what will that reduce to? Pi over 2. You guys are good at this. Let me do number 4 next. We'll do another easy one before we do, because this one's going to get a little bit messy. Let's do number 4. You're going to take your 240 degrees, multiply it by pi over 180. The degrees cancel, the zeros also cancel. So you get 24 pi over 18, and we have to reduce that. So 24 and 18 will both divide by what? Good, they'll both divide by 6, so that'll be 4 pi over 3. All right, let's go back and get number 3. That one's going to be a little bit messy because it doesn't end with a 0. You're going to take your 115 degrees, multiply it by pi over 180, and the degrees will cancel. Now, the thing is, we have to reduce that. 115 and 180 will both divide by 5. Some people can just do that in their head, 115 divided by 5 and get the answer. If you want to write it out off to the side, I'm going to do that. I don't care how you get it, but you don't get a calculator, and so you have to get it somehow, okay? I'm going to do the long division. 5 goes into 11 how many times? Twice, good. 5 times 2 is 10, subtract. That would give you 1, you bring down the 5, do it one more time. 5 goes into 15 3 times, good. So 23, so our numerator is 23 pi. There are a million ways you can get through this, however your brain works. Everybody's brain works differently. You have to appreciate that I'm doing the problem in front of a whole group of people, so I kind of have to like work out every last little thing to get everybody there. Now 180 divided by 5, you're gonna do a lot, so you probably end up like accidentally memorizing that one, but let's work it out once here. 5 goes into 18 3 times. Subtract, you would get 3, bring down the 0, 5 goes into 36 times. So the denominator is 36. Will 23 over 36 reduce any further? No, it won't, because 23 is prime. So 23 pi over 36 is your answer. And that's a great answer, don't discriminate. And then number 5 is going to be an easy one again. How can I tell from looking at that it's going to be easier? Yeah, it ends with 0, so the zeros are going to cancel. Take your 270 degrees, multiply it by pi over 180. The degrees and the zeros are going to cancel. You get 27 pi over 18. So 27 and 18 will both reduce by what? Both divide by 9. So that will be 3 pi over 2. Honestly, this is more like fractions than anything else. It's like reducing fractions. Now we're going to go the other way. So instead of multiplying by pi over 180, we're going to multiply by 180 over pi. All right, so take your pi over 4 radians, multiply it by 180 over pi. And that time, what's going to cancel? The pi's. Like, I get people that are always like, oh, I'm scared I'm going to mix it up. If you do, you will catch it because the pi's won't cancel or the degree symbols won't cancel. All right, so we get 180 over 4. Once again, there are a million different ways your brain can think through that, but somehow, because I'm not going to give you a calculator for this, you've got to do 180 divided by 4. I'm doing the problem in front of everybody, so I'm going to do the long division so you can see every step. 4 goes into 18 4 times. Subtract 16, you would get 2, bring down the 0. 4 goes into 25 times, so 45 degrees. And I put the degree symbol there for you. You can write it again if you want to, but I put it on the paper for you. All right, pi radians. You're going to take pi, multiply it by 180 over pi. I actually don't even know why I put this on here. I guess that we could talk about it, but these cancel and what do you get? Yeah, like that is the conversion. It would be like if I asked you 12 inches is how many feet? You would just be like, well, 1, like it is the conversion. All right, let's try this one. 10 pi over 9 times 180 over pi. The pi's are going to cancel. And then you have to get through reducing that somehow. Here's my suggestion. Leave the 10. All right, so just leave that be. Do 180 divided by 9, because I think that's easiest to do. What's 18 divided by 9? 2, so it would be 20. 180 divided by 9 would give you 20, and then multiplying those isn't so bad. That would be what? Be 200 degrees. Sounds like we're setting our oven or something. Although 200 is not very hot for me. All right, 16 pi over 9. Times 180 over pi. Pi's are going to cancel. And again, my suggestion is do the same thing. Leave the 16 alone and divide these. 180 divided by 9 would be 20. And then multiply those together. So it's 16 times 2. It'd be good, 32, and then just add the 0, so 320. There, we could bake cookies at 320 degrees. Still not very hot. All right, and then 2 pi times 180 over pi. The pi's cancel. You get 2 times 180, which is 360. And again, that's like the conversion. It's just the whole way around. All right, so we just did all the conversions. Now we're going to look at drawing the angles. We're not going to get out a protractor and measure them. As long as you're in the correct quadrant, you're good. So you have to just accept that it's going to be good enough. So an angle is formed by rotation. An angle is formed by rotating a ray about its vertex. Do you remember in geometry you did segments, lines, and rays? A segment was like stopped on both sides and a line went on forever on both sides. What was a ray? Yeah, like a point on one side and then looked like an arrow, sort of, okay? So you're gonna take that and rotate around its vertex. Positive angles rotate counterclockwise. And negative angles rotate clockwise. I write that up here, but like, it's almost an outdated thing to say clockwise and counterclockwise because almost no one uses an analog clock anymore. Do you know what I'm saying? Like, does anyone use an analog clock? Like yours are all digital on your phone, right? So here's how you want to remember. The positive ones are going to rotate up. The negative ones are going to rotate down. So it kind of makes sense. Positive up, negative down. Coming with me on that? Like that makes sense, right? So here's what this is going to look like. Draw your coordinate plane. Your X and Y axis. And you're always going to start here. This is always going to be the initial side. Initial means starting. So that's your initial side. It's always going to be right there. And then just watch me take the marker and rotate it. This is like our ray. If you're rotating positively, it's just going to go like this. Do you see what I'm saying? And it can keep on going and it can go around and around as many times as you want. If you go negatively, it's going to rotate like this. Okay. But let's say we rotate positively and we stop like right here. That is what's called the terminal side. So you start at the initial side, you end at the terminal side. And then this, that amount of rotation, that's your angle. And we call angles theta. That's just typically the variable that we use for this. I'm going to label some other stuff on here just so that you can get used to it. If you have not rotated anywhere, you have gone 0 degrees, which is in radians, 0 pi. A lot of people will just put 0, but here's my suggestion to you, because I know where we're headed with all this radian stuff. Say 0 pi, like no pi, so it doesn't confuse you, okay? Just get used to doing that, 0 pi. Now, if we rotate up to here, I'm about to throw a question at you. If we rotate up to the top, how many degrees did we go? 90, good. This would be 90 degrees, which in radians is pi over 2. We did the conversion on the other side. You can look back, but again, you're going to have to start getting used to some of the like standard ones. All right, let's say we rotate over to here. How many degrees did we go? 180, good. Do you remember what that is in radians? 180 degrees. Good, 1 whole pi. Now it gets difficult for me to like rotate it even further because like my hand is attached to my body, okay? But let's say we rotate the whole way down to here. How many degrees would we have gone? Good, if you go all the way down to here, like this is 180, if you keep going another 90, that's 270, and that would be in radians, 3 pi over 2. And if you go the whole way around, that's 360 degrees, which would be 2 pi, lands in the exact same spot. And you can keep going. Like you can rotate around and around and around and around and around. Or you can go negatively around and around and around, okay? So what the directions say for these is we're gonna convert them to degrees and radians, so you can see both, so it's just like we did on the other page, and then we're gonna draw it. Again, it's not going to be perfect. If you get it in the correct quadrant, I'm happy. And there's only 4. Oh, let's label them. Which quadrant is this? 1, and they are Roman numerals, guys. And then this is 2. And then this is quadrant 3. And this is quadrant 4. So 1, 2, 3, 4. Yeah, 4 is IV in Roman numerals. All right. So first, let's do the conversion. 45 degrees. What would we multiply by to turn that into radians? You can look back if you need to, because I only just taught this to you. Pi over 180, good. And the way you can remember is those degree symbols have to cancel. So what we end up with is 45 pi over 180. Those will both divide by 5. 45 divided by 5. Good, 9 pi, and 180 divided by 5 is 36. We did that on the other side. You're going to do that one a lot. You might just want to know that that's 36. That'll actually reduce again. 936 will be 1/4, so pi over 4. And then we're just going to draw it. Again, I don't care what it looks like. You just have to get it in the right quadrant. So I should pause when I say this, but I won't. You have a 1 in 4 chance of guessing correctly. Do you get what I'm saying? There's only 4 quadrants. Your world is very small. What quadrant is 45 degrees going to be in? If we start here and rotate that way. First, quadrant 1, it's going to look like that. That's it. That's drawing the angle. You just pick what quadrant it is and show me what direction you rotated. We rotated positively, so it went up. That's it. Let's try another one. Multiply by pi over 180. All right, so here the zeros and the degrees will cancel. We have 21 pi over 18. What will those, bless you, what will those both divide by? 3, good. So it'll be 7 pi over 6. And all you have to do, bless you, is figure out what quadrant it is in. So which quadrant is that amount of rotation going to put us in? Third. And you just have to show what direction you rotate. That's it. It's not like a fancy picture or anything. It's just where did it end up? Oh, this one's negative. Again, change it into radians. We're going to multiply by pi over 180. The zeros and the degrees cancel. this will be negative 24 pi over 18. They'll both divide by 6, so negative 4 pi over 3. Now, when you go to do this one, be careful about what quadrant you end up in, because this time we're going to start by rotating downwards. This is rotating negatively. It starts out going down. So if we go negative 240 degrees, where is that going to put us? Second, good. And so it would look like that. Now we're going to do a few the other way. These are given in radians. 3 pi over 4. This time you're going to multiply by 180 over pi so that the pi's cancel. And same thing we did on the other side. Here's my suggestion. And again, however your brain does it is fine, but you're not going to get a calculator. Leave the 3 alone and do 180 divided by 4, because that'll make the number smaller. 180 divided by 4 would be 45. And then multiply those together. Let me see, 45 times 3, 135. See, some people have a calculator in their brain, which is cool. All right, so drawing it, what quadrant is that going to put us in? 2, good, second quadrant. No, if you can just do it in your head, that's fun, is the answer. Again, I'm doing the problem in front of everyone though. So like as the teacher, I try to write down every last little thing. But like if you can do this in your head, like more power to you. All right, negative pi over 3, multiply it by 180 over pi. Pi's are going to cancel. And that will be negative how much? We got 180 divided by 3. Good, negative 60. So if we go negative 60 degrees, what quadrant are we in? 4. Good, and we went backwards. And then last one, 11 pi over 6. We're going to multiply by 180 over pi. The pi's cancel. And again, my suggestion is leave the 11 there. Do 180 divided by 6, because that's a little bit easier. That would be 30. And so that would be 330 degrees. But again, however your brain does it is fine. What quadrant would 330 degrees be in? 4th, good. 360 is the whole way around. I like that one because it looks like Pac-Man. You went like almost the whole way. We'll do a little bit more and then I'll give you another break. I realize the notes are a little bit longer today than usual. All right. Vocabulary, coterminal angles. They have the same terminal side, so they end in the same place, but they have a different amount of rotation. Here's what this is like. Pretend you and me were out on the track and pretend that it's a perfect circle. I stand exactly where I'm at and you run around the track 10 times and then end up back with me. We're at the same place, but you ran way further than me. Do you get what I'm saying? It's like where they end at the same place, but different amounts of rotation, okay? So what we're gonna do is draw these, the visual helps, and then we're gonna state a positive and a negative coterminal angle. There are an infinite number of answers because you can go around and around and around the circle as many times as you want, okay? So we're gonna get one positive and one negative answer. First, let's draw this. 150 degrees, what quadrant would that put us in? 2, good, quadrant 2. Now, if we want a positive coterminal angle, just watch me point to it. So we went 150. If we still want to end at the same place, we would just need to go around again. Do you get what I'm saying? Like you would go 150, and then if you went around again, you would land at the same place. So what is the whole way around work? 360. So you're going to do 360 plus 150, and that will give you your answer. You just did an extra rotation. So that would be 510 degrees. That's your positive answer. Now for the negative one, you could start here and go the opposite direction. Do you see what I'm saying? That's like if we're out on the track and I say, you go that way and I'll go this way and we meet somewhere around the other side. So we want to go negatively. How could you get, oh, I didn't go far enough though. Whoops. I'm sorry. Got to go all the way until I get there. How could you get that answer, like this amount? Good, subtract it. So 360, because that's the whole way around, minus 150 would be 210, except what do you have to put in front of that 210 to indicate that you went backwards? A negative. Good, just put a negative in front of that. So negative 210 degrees is your other answer. So you either add on one full rotation or you subtract it off. You either add or subtract, that's it. Okay. Well, I usually ask for both answers, one positive and one negative. So you would do both. Now, here's where we always run into a little bit of a snag because this one is in radians. You can't convert it to degrees and just do it in degrees. You have to get used to the radians. And again, I always get somebody that's like hanging on to those degrees. You got to start to let go. And here's that moment. Letting go can be uncomfortable, but you're all going to be okay. Let's flip back here. The whole way around was 360 degrees. What is that in radians? Get used to the whole way around being 2 pi. Okay, so let's go ahead and draw this one. What quadrant would 4 pi over 3 be in? I will tell you, but I want to throw the question out first. 4 pi over 3. It is not 4. 3. It's in quadrant 3. Here's why. This is 1 whole pi, which would be 3/3. 3/3 would be 1 whole pi. If you went 4/3, you went a little bit further. Does that make sense? It's 1 1/3. So we went to there. You'll get there. That was the very first time I asked you that question. We're going to spend the whole unit on it. You're going to get there. Okay. Again, this is 1 whole pi. We went a little bit further than 1 whole pi. Okay. Now the whole way around is 2 pi. So we're going to do the exact same thing that we did here. If you want a coterminal angle, you just want to add on a rotation. So you would do 2 pi plus 4 pi over 3. Now here's the thing. To add those together, you need a common denominator. So I need to change this into thirds. How many thirds is a whole 2? Good, we've done that before. Be 6 pi over 3 plus 4 pi over 3, which would be 10 pi over 3. That's your positive answer. To get the negative one, you're going to subtract. It would be this amount. This is like, hey, you go that way, I'll go this way. We'll meet somewhere around the other side. So you would take the whole way around, which we just said was 6 pi over 3. That's a whole 2 pi. And subtract your angle. What is that going to give us? Good. 6 minus 4 is 2. So 2 pi over 3. But what do you put to indicate that you went backwards? A negative. Just slap a negative in front of it. All right, I got asked a really good question, so I'm going to address this. Again, you don't have to write this down, but just watch. I tend to like not really go much beyond 1 full rotation, but you know Delta Math is going to do that. So like here's some that go above 360. So say you had to do 460 degrees. Well, 360 is 1 whole way around, and then you went an extra how much? An extra 100. So what quadrant would that put you in if you go an extra 100? 2, and it would look like this. Watch, it actually looks kind of cool. You go the whole way around and then land there. I know, fancy, right? It looks like a little snail. So how about 750? Well, the whole way around's 360, so what would twice around be? 720? You're shaking your head at me. You skateboarders in here. 720, and then if you went a little bit further than 720 to 750, what quadrant is that going to put you in? 1. So watch how this one goes. You go around once, that's 360. Again, that's 720, and then you land there. Sweet, right? All right, here they are in radians. 13 pi over 4. The whole way around is 2 pi. That would be how many fourths? 8 fourths is the whole way around. We went an extra 5 fourths. Do you see what I'm saying there? What quadrant is that going to put us in if we go an extra 5 fourths? Good. You guys are getting it because this is 4 fourths. So 5 fourths would put you here. You go the whole way around and then you would land right there. Now, how about this one? Again, the whole way around is 2 pi. How many sixths is a whole 2 pi? 12 sixths. So if we went 13 sixths, we just went a little bit further. What quadrant does that put us in? Guys are getting it. It would look like that. Sweet. Okay, let's finish the notes. You guys are being good sports. All right, last piece of vocabulary we're going to do is a reference angle. This is the acute. And what does acute mean again? Smaller than 90. All right. It is the acute angle with the x-axis. And underline that because I get people to draw that with the y-axis and that would not be correct. All right. It's the acute angle with the x-axis. You'll sometimes see it written like this, like a theta with a little prime next to it, like a little apostrophe. It is never negative. Or you know what? I'm going to change that and say it's always positive because that feels a little bit like, I don't know, saying it's always positive just sounds like happier. It is always positive. So don't ever write a negative reference angle. I did one of these in each quadrant so you can see how it turns out each way. We're going to draw it and then label the reference angle. All right, what quadrant is 45 degrees in? 1. So your reference angle just is 45 degrees. If you're in quadrant 1, your angle is your reference angle because you didn't go far enough for it to be any different. All right, what quadrant is 210 in? 3, good. And I like how you guys pause and think about it first, not just shouting out an answer, right? Quadrant 3, this portion of it is the reference angle. Again, it's the acute angle with the x-axis. So that would be, let's see, straight line is worth 180, but we went to 210. So like how much further did we go? How much? 30, good, perfect. These ones are in radians, so you have to stick with the radians. Deep breaths, you're gonna be all right. Also, we went negative. Think about it, negative 5 pi over 6. 6, it always sounds like I'm listening when I do this. 6 would be 1 whole pi. So if we only went 5, 6, we like didn't quite make it, but remember we went backwards. So what quadrant is that? Okay, look, you're rotating backwards, so you're going this way, right? This would be, oh, did it just pause on me? All right, look, if you rotate backwards, we're going this way, right? This would be 1 whole pi, 6, but we didn't quite make it. We only went 5, 6, so it's gonna be in quadrant 3. It's gonna look like that. And this portion of it is the reference angle. Again, it's always with the x-axis. So look, if this amount is 5, 6, what is this little guy? 1/6, good. If that's 5, 6, this has to be 1/6 to make it to 6, 6. Again, 1 whole pi is 6, 6. 7 pi over 4. What quadrant's that going to put us in? Just stop and think about it. It's fun with fractions. It's 4 because the whole way around would be how many fourths? Good. The whole way around is 2 pi. So the whole way around is 8 fourths. We only went 7 fourths. Looks like Pac-Man. This is your reference angle. So if oh, we said it already. If this is 7 fourths, what is this little guy? 1/4. So just pi over 4. All right, last thing we're going to look at are your arc length and sector area. This is kind of like last unit where I'm going to give you a formula, you're going to remember it and then plug in and get your answer, right? An arc length, they use S for that, which I'm not sure why, but S equals, it's the easiest formula in the world, R theta. That's literally it. You just take the radius of the circle, multiply it by the angle, which is cool. Sector area is 1/2 R squared theta. Here's the only thing. Both of these thetas, whenever you use this, have to be in radians. So if it's not radians, you have to first convert it. That's the only thing. But I like these formulas. These are cool. You can disagree, I know, because you're tired and it's Friday, but this is neat. Here's what we're finding. If you have a radius of 5 inches for your circle, draw yourself a circle, your radius is 5 inches. So that's 5. Imagine like a pizza or something. Well, I guess that'd be a really tiny pizza. Imagine a pizza for like $1 or something. Now we want to rotate 225 degrees. I know I didn't draw quadrants on here, but if you go 225 degrees, what quadrant would that put you in? 3, so that would be like kind of down this way. All right, if you go 225 degrees, here's what this formula is going to give us. This distance. Isn't that cool? You can find a distance even though it's curved. That's neat. You can disagree all you want, but that's cool. Now here's the only thing, that's in degrees, so we have to change it to radians. I feel like we may have done 225 degrees earlier today. You want to look through and see if we already converted that one? If not, we can do it. But if we already did it, I'm not going to make you do it again. Did we do 225? No? Okay, that's fine. We can do it. We will multiply by pi over 180. They'll both divide by 5. 225 divided by 5. Let's see, that would be 45. 180 divided by 5 is 36. I kind of just know that one because I've done that so much. And then those will both divide by 9. So 5 pi over 6. No. Wait, I messed something up though. Did I do that wrong in my head? No, I did that right. So 5 pi, oh, 5 pi over 4. There we go. You're right. I said 6, but I meant 4. Phew. 5 pi over 4. There we go. All right, so plugging it into the formula, it's just the radius times the angle. So our radius was 5, and our angle is 5 pi over 4. And 5 times 5 is 25. So it would be 25 pi over 4 inches. And that is the length of this amount, which is cool that you can find it even though it's not a straight line. And then last one, draw yourself a circle. I guess I liked the number 5 the day that I made up these notes. This time your radius is 5 centimeters, so I guess it's even smaller. What's nice about this problem though is that I gave you the angle in what radius, so you don't have to do a conversion, which is nice, okay? We're gonna find the area. Now, if we rotate 2 pi over 3, I know I didn't draw quadrants on here, but what quadrant would this be in? 2 pi over 3, think about it. Good, because 3/3 would be the whole pi, straight line. 2/3 would be like right about there. Now, what this formula gives you, this one's super cool, is this area. Like you're actually finding that area. So you can find like the area of how much pizza you ate. Like that's neat. All right, so plugging into the formula, it's 1/2 r squared, which in this case was 5, and then times theta, which is the 2 pi over 3. So these 2's are going to cancel, which is nice. 5 squared, 25, so 25 pi over 3. Units for this one, because we found an area, will not be centimeters, it'll be centimeters squared. Good. Remember like the last 2 on your test where it was like square feet because you found an area? Just like that.